In 1935, engineers at the Italian company Ansaldo developed a combat vehicle with a design feature involving the operator being inside without the ability to sit down. The soldier was forced to move in a crouch, simultaneously driving the vehicle and firing the machine guns. The vehicle was named the MIAS. Due to the specifics of the design, the Italian military refused to adopt this model for service. This project went down in the history of military hardware as an example of an unsuccessful engineering solution in the field of Italian tank construction. The mid-30s of the 20th century was a period of change for Italy. After the Fascist Party came to power, a militarization program began, aimed at strengthening the country's military status in Europe. The government planned to modernize the army and equip it with modern weaponry. The defense industry received investments and orders for the development of new types of weapons, from artillery to armored vehicles. During this period, the activity of a large industrial enterprise intensified, namely the Ansaldo company from Genoa. Founded in 1853 by Giovanni Ansaldo, by the 1930s, the firm was one of the main manufacturers of armaments in the country. The company specialized in the production of heavy artillery, hulls and turrets for tanks, anti-aircraft guns, and shipbuilding, holding leading positions in the production of artillery systems before and after the First World War. During the years of the First World War, the scale of the company's production increased. Factories operated in a continuous mode, producing guns, shells, and equipment for the Army. By the end of the war, the value of the company had grown from 30 million to 500 million lira, and the number of personnel had reached 80,000 people. However, after the end of the war, Ansaldo, like other defense enterprises, faced an economic downturn. Due to the reduction in military orders and the drop in demand for weaponry, the company found itself in a difficult financial position. The Perrone family, which owned the concern, exited the business in the early 1920s. For a decade, the enterprise experienced difficulties, despite attempts at diversification and switching to civilian products. The situation changed with the start of the new militarization program. In 1935, the management of the company was taken over by engineer Agostino Rocca, who reorganized the structure of the enterprise to fulfill state military contracts. During this period of production recovery, engineers began work on a project for a motorized mobile shield for infantry. The concept was based on the experience of the First World War, associated with casualties when crossing open terrain under fire. In strategic planning, the influence of trench warfare ideas persisted, despite the development of mobile warfare doctrines. The goal of the Ansaldo development was to create a means of protecting infantry from machine gun fire, allowing them to approach enemy fortifications. The result of these developments was the MIAS project, MIAS, Motomitragliatrice Blindata d'Assalto, which translates as Armored Motorized Assault Machine Gun Vehicle. According to the technical assignment, the plan was to create a compact tracked armored vehicle armed with machine guns to accompany infantry, provide fire support, and cover. The implementation of the project by Ansaldo engineers had a number of specific features. The MIAS was a small-scale armored structure on a tracked chassis. Technically, the device was classified not as a tank, but as a motorized shield with mounted weaponry. The dimensions of the machine were small. The exact dimensions are a subject of discussion, but it is known that the hull was designed for one person. The design did not provide a seat. The operator had to control the machine while inside and moving in a crouching position. Thus, the equipped serviceman was forced to move on bent legs while simultaneously operating the levers and firing. Ansaldo engineers justified this decision with the desire to maximize the reduction of the vehicle's profile to decrease the target area. The MIAS armor was designed taking into account the experience of the First World War and the characteristics of small arms of that period. The front steel plate had the greatest thickness and was intended for protection against Mauser armor-piercing cartridges of .31-inch caliber, marked SMK, pointed bullet with a steel core. These munitions were used by the German Army and could penetrate armor up to .55 inches thick when hitting at a right angle. The calculation for the frontal armor assumed resistance to the impact of such projectiles from a distance of 164 feet at an angle of 90 degrees. The side plates were thinner and provided protection against the standard Italian cartridge of .26-inch caliber of the model 1891, a bullet weighing 160 grains, under similar conditions. The roof consisted of two parts. The rear section was hinged and could be raised, creating an additional armored visor over the operator's head. A design feature was the absence of armor in the rear and lower parts of the machine. As a consequence, the operator's legs in the lower part and the rear side of the hull remained open. As a power plant, a single-cylinder Frera gasoline engine with a displacement of 15.3 cubic inches used in motorcycles was utilized. The Frera company was an Italian manufacturer of motorcycle technology founded in the early 20th century in Tredate near Milan. By the mid-1930s, after the economic crisis of 1929 and the loss of contracts, the firm was in a difficult financial position, declared bankruptcy in 1933, and closed in 1936. The engine developed a power of 5 horsepower at 3,000 revolutions per minute and was equipped with a Morelli magneto ignition system. The transmission included 3 speeds, 2 forward and 1 reverse. The maximum forward speed was 3 miles per hour, which is comparable to the speed of a pedestrian. When moving backward, the speed decreased to 1.4 miles per hour. The tracks were made of high-strength steel links. The driver controlled the direction of movement by means of a lever that regulated the tension of the left or right track. Track tension adjustment was performed by moving the road wheel forward or backward. This control system required physical effort from the driver. Moreover, control was carried out in a position on bent legs inside the hull. The armament of the MIAS machine consisted of 2.26-inch Scotti machine guns manufactured by the Isotta Frassini Company. Alfredo Scotti was the developer of an automation system with a gas-operated delayed blowback mechanism for automatic weapons in the late 1920s. His designs were manufactured by a number of firms, including the Swiss Oerlikon and the Italian Isotta Frassini, a major manufacturer of automotive and aircraft engines. The machine guns were rigidly mounted in an installation on the front armor plate with limited aiming angles, 24 degrees vertically and 10 degrees horizontally to each side. The ammunition load consisted of 1,000 cartridges in 40 magazines placed inside the hull. This supply was calculated for several minutes of continuous firing. Besides the main MIAS version, Ansaldo engineers developed the MOAS modification, which stands for Armored Motorized Assault Mortar Machine. The variant retained the design of the hull, chassis, and engine, differing in the composition of armament. Instead of machine guns, a 1.77-inch rapid-fire Brixia mortar was installed, developed by the Tempini Company in 1932. A feature of the mortar was the use of a magazine with blank cartridges to fire a separately loaded mine. The early version of the design was equipped with a magazine for 5 mines with manual reloading. The mortar was rigidly attached to the front armor plate. The elevation angle reached 82 degrees, which ensured the possibility of delivering high-angle fire. Horizontal aiming was 5 degrees to each side, which is less than the similar figure for the machine gun version. The ammunition load included 50 high-explosive fragmentation mines and 50 propellant charges placed inside the hull. The muzzle velocity of the M35 high-explosive mine was 272 feet per second, and the maximum rate of fire was 1 shot every 2 seconds. Theoretically, the armament was intended to suppress machine gun nests and fortifications. However, the practical effectiveness of the system was evaluated ambiguously by specialists. Prototypes of the MIAS and MOAS were presented to a military commission to assess their combat potential and the feasibility of adoption for service. The patent from June 13, 1934, authors Bongiovanni, Muri, and Bassin, may indicate that the development was conducted by order of the Army and not as part of a private initiative. On the manufacturer's technical drawings, the vehicle was designated by the index AB13, which was an abbreviation for Auto Blindo, armored vehicle. The number 13 likely indicated the 13th year of the fascist regime. The date on the drawing was illegible, but presumably referred to January 28, 1936. Initial trials revealed design flaws that cast doubt on the suitability of the MIAS and MORAS models for use in combat conditions. The main problem was ergonomics. The crew was forced to stay inside the vehicle in a squatting position. The serviceman had to balance in a semi-bent position while simultaneously operating levers, conducting observation through viewing slits, and using the armament. Operation required significant physical effort. After a short time working in such a position, numbness of the limbs and muscle spasms occurred, and coordination was impaired. In a combat situation, such physical exhaustion could negatively affect the crew's actions. The vehicle's movement speed was also assessed by observers as unsatisfactory. 3.1 miles per hour corresponded to the speed of a pedestrian. This allowed the enemy to track the equipment's movements, take aim, and deliver methodical fire. For artillery crews, the vehicle represented a slow-moving target. Infantry could also approach the tank to use grenades or incendiary mixtures. The concept of a motorized shield assumed movement ahead of the attacking infantry to cover it from fire. However, at the indicated speed, soldiers could overtake the armored vehicles, remaining without protection. The absence of armor on the rear part of the hull made the vehicle vulnerable. An enemy located behind or to the side had the opportunity to hit the crew, which was open to fire from these angles. The soldier's legs below the ankles stuck out from under the body of the machine, presenting a target for small arms fire. A hit to the leg incapacitated the crew and immobilized the vehicle. In conditions where attacks could come from various directions, this level of protection was deemed insufficient. By the mid-1930s, global military doctrine had evolved toward mobile warfare. The experience of World War I demonstrated the inefficiency of static trench warfare. The new concept relied on rapid breakthroughs by armored vehicles, flanking maneuvers, and encirclement operations. Tanks were viewed as a strike force capable of covering long distances, coordinating with aircraft and motorized infantry, and executing maneuvers. Italian military theorists were also beginning to recognize the need to shift to mobile operations, although some of the high command clung to older views. In this context, the MIAS tank appeared technically obsolete. A motorized shield moving at walking speed was unsuited to the changed conditions of combat. The machine's slow advance gave the enemy time to regroup, bring up reserves, organize a defense, or retreat. The mission of protecting infantry during an attack remained relevant, but it required a different technical solution. For example, the use of fast light tanks capable of supporting the advance and suppressing enemy fire. Italian military specialists tracked armored vehicle development trends in other nations and formulated requirements for modern combat vehicles. Limited weapon traverse angles were cited as one of the shortcomings of the MIAS project. The elevation angle was 24 degrees and horizontal traverse was limited to 10 degrees to each side, allowing the crew to fire only within a narrow frontal sector. In the event of a flank attack or the appearance of a target outside the firing sector, the entire vehicle had to be turned using the track control system. Given the slow movement speed and the need for the operator to maneuver while in a hunched position, turning took time, during which the vehicle's protection was compromised. The MOAS variant, equipped with a mortar, had similar characteristics. Despite an elevation angle of 82 degrees, the horizontal traverse of 5 degrees limited the weapon's effectiveness against moving targets. The Military Commission issued a negative report. The MIAS and MORAS projects were deemed untenable, and the tanks were considered unsuitable for modern combat. No production orders were placed. Development never advanced beyond the prototype stage. Ansaldo engineers created a design that combined elements of outdated concepts with the technical flaws of new solutions. The motorized shield could not compensate for the shortage of armored vehicles in the Italian military needed to realize the government's plans for territorial expansion. The cancellation of the MIAS project negatively affected the standing of the Ansaldo company, which had planned to strengthen its position in the arms market. The concern's leadership had counted on a mass production order for infantry units. The military's rejection resulted in the loss of potential contracts and the resources spent on research and the creation of prototypes. Amidst the arms race in Europe in the mid-1930s, the company continued working on new projects. Italy needed modern tanks to support the foreign policy objectives of the Mussolini regime, and Ansaldo was faced with the task of proposing an alternative to the rejected project. Information regarding the further fate of the MIAS and MORAS prototypes is missing. No documentary evidence of the vehicle's use has been preserved following the refusal to adopt them into service. It is known that the prototypes were not transferred to the troops for training or experimental purposes. Presumably, the vehicles were dismantled at the Ansaldo plant in Genoa, and their components were scrapped or applied in other developments. The Scotti machine guns and Brixia mortars used on the prototypes found application in the Italian Army during the Second World War as means of air defense and infantry support. By the mid-1930s, the Italian Army was experiencing a need to update its fleet of combat vehicles. The foundation of the armored forces consisted of Fiat 3000, created based on the Renault FT after the First World War, and tankettes of the CV-33 and CV-35 series, developed based on the Cardin Lloyd. These light vehicles with machine gun armament demonstrated low effectiveness during combat operations. In 1935, in Ethiopia, Italian tankettes were subjected to attacks by enemy infantry. In a number of cases, Ethiopian fighters managed to disable the vehicles by blocking the operation of the running gear with elements of equipment such as spears. In the autumn of 1936 in Spain, the situation changed when Italian units entered into combat contact with Soviet T-26 tanks transferred to the Republican forces. The Soviet vehicles possessed a technical advantage over the Italian tankettes and German PZ-KPFW-1 tanks of Modification A. Combat operations at Guadalajara in March 1937 revealed the vulnerability of the Italian armored units. The Republican T-26 inflicted fire damage on the CV-35 models, the armament and armor of which were inferior to the 1.77-inch guns of the enemy. After these events, the Italian command sent a request to Germany for the supply of anti-tank weaponry, and also considered the possibility of sending obsolete Fiat 3000 tanks equipped with 1.46-inch guns, to Spain. In January 1935, practically simultaneously with work on the MIAS project, the Italian Army issued an order to the Ansaldo Company for the development of a new tank designed for operations in mountainous regions. The mass of the vehicle was limited to 8.8 to 9.9 short tons, which was dictated by the load capacity of bridges in the anticipated theater of military operations. The new project received the designation Carro di Rottura 10T, breakthrough tank with a mass of 11 short tons. In May 1936, a classification was adopted according to which all medium and heavy infantry tanks were designated by the term Carro di Rottura. By the end of 1936, the first prototype was prepared for trials. This vehicle, which subsequently received the index M1139, differed structurally from the MIAS project. The tank had a classical layout with a crew of 3 people, individual workstations, and reinforced protection. Initially, the prototype was armed with a 1.46 inches Vickers-Tierney cannon, 40 calibers in length, installed in the frontal part of the hull, and 2 0.26 inches Scotty machine guns in a polyhedral turret. The design of the tank, specifically the suspension and the system of road wheels, was based on the technical solutions of the British 6.6 short tons Vickers tank. At the same time, proprietary changes were made. The placement of the final drives and reduction gears inside the front drive sprockets allowed for the elimination of the enlarged final drive housings in the nose section of the hull. In subsequent years, the prototype was refined based on the results of trials. Initially, a 6-cylinder gasoline engine with a power of 84 horsepower from a Fiat 634N truck, also used in the Ansaldo 9T, was installed on the tank. Later, the power plant was replaced with a more powerful diesel engine, Fiat SPA 8T, with a power of 104 horsepower. The Scotty machine guns were replaced with Breda 38 models of 0.31 inches caliber. The turret was replaced with a design of a round shape, and periscopic observation devices were installed on the roof. By 1938, changes had been made to the turret design. Welded joints were replaced with riveted ones. On January 11, 1938, an Army order was placed for the production of 100 units of the new tank under the official designation M11. The numerical index indicated a mass of 12.1 short tons. Production of the M1139 model proceeded at a slow pace due to a shortage of materials and components. The production capacity of the Ansaldo Company allowed for turning out 9 vehicles per month. To fulfill the order, they used 1.46-inch guns removed from obsolete Fiat 3000 tanks. By October 1939, 22 units were ready, and the last vehicles were handed over to the Army in May 1940. By this time, the transition had begun to the upgraded M1340 model, equipped with a 1.85-inch gun in a turret mount instead of the hull. The M1139 model technically surpassed the MIAS project, demonstrating the capability of Italian industry to produce armored vehicles consistent with global trends of that period. The MIAS project was closed following an official rejection by the military. The prototypes remained at the Ansaldo factory and were likely sent for scrapping or dismantling. Documentary evidence regarding the further fate of these machines is missing. Development in this direction was ceased in favor of other projects. The armament, machine guns and mortars, removed from the prototypes, found application in other types of equipment and was used by the Italian Army during the Second World War. The experience gained from working on the MIAS influenced the further development of Italian tank building. The irrelevance of trench warfare concepts and conditions of mobile combat became obvious. A need was identified for full-fledged tanks of a classical layout, possessing adequate protection and speed, instead of motorized shields. This contributed to the fact that subsequent developments, including the M13 and M14 series, were based on traditional design solutions, even though the technical characteristics of the produced machines fell short of the counterparts fielded by allies and adversaries. The MIAS and MOAS projects are viewed in the history of armored vehicles as examples of designs that did not meet the requirements of modern warfare. These small-scale tracked machines, which involved a specific crew placement, are evaluated by specialists as technically flawed specimens. The closure of the project demonstrated the necessity of designing military equipment based on real tactical needs and conditions of combat application, rather than solely on engineering concepts.